Okay, y'all, so we have notes 1.2, the recursive, I didn't even finish writing it, equation, and its column. Okay, so we have these columns here, n and f of n, and you have probably seen columns like this before, but in a previous life you probably saw it as like x and y like this. Well, right now we're not dealing with continuous items right now, then that's a word we'll learn later. So we use n and f of n with sequences, with arithmetic sequences and with geometric sequences. Now it won't always be an n that's in the middle here, but we do use that letter n quite a bit for our class. But it might be x in here, so there's no need to panic if you see that. So this n column is usually what I like to call our time column, because when we get to word problems, that's typically what will go here is the time. And then this f of n column, we've been drawing a lot of dots, so I kind of call it our dots column right here. So to explain, time 0 we have 2 dots, at time 1 we have 6 dots, and then at time 2 we have 10 dots, right? And these are each of our rows that are going on, okay? So this is row 1, this is row 2, this is row 3, and then as we are going down this table, we see that we are adding by 4, which makes this an arithmetic sequence. So this 2 here is the number we start with, or the dots we start with, and in a recursive, we just start with that 2 in the first column. And then because we're adding by 4, we would write this next row's recursive piece as 2, ooh, that's a terrible color, 2 plus 4, right? Because we had to add 1 4 to get that 2. And then for the next row, we would do it again. We would have 2, but in this case, we would have added that 4 2 times. So we have 2 plus 4 plus 4. So from the original to that third row here, we added 4 twice. Now, if we wanted to figure out a row 4, right, what would be next? Well, we would have time 3 next, and we would have 14 next, and we would have 2 plus 4 plus 4 plus 4 for that recursive column. So that's if you were asked to find the next row. And a recursive is going to be written as the following. If I write this in pencil, it means it'll be there every time. And anything in the colors here, that means that those might change depending on our tables, right? So a recursive equation always goes f of n equals f of n minus 1. Always, this is always how it starts. And then we add 4, because that's the math that we're doing down our table. That's our common ratio or our common difference. Then typically you'll see a semicolon, and sometimes this next piece is written next to it, sometimes it's written under it. But with the recursive equation, you also have to show what you start with. Okay, so what we start with is f of 0, right? We start with that time 0, and at that time 0 we have this 2 dots, okay? So with the recursive, you always have to give your, what I like to call your starting numbers, okay? But we did all this work here for this equation that's got these 2 separate pieces. So let's look at number next. We have time 5 with 3 dots, time 6 with 15 dots, and time, I'm noticing a boo-boo here, bear with me for a second. times 7 with 75 dots. Okay? So, fix that boo-boo. Good job. That means our recursive column is going to start, well, we started with 3 dots. And as we're going down this column, now that we've fixed it, we see that we are multiplying by 5, right? 3 times 5 is 15. And then 3 times 5 twice would give us that 75. So as we go down, we have a geometric sequence using a common ratio of 5. If I wanted to figure out the next row, right, what would this row be? Well, this would be 8, and that would be, I'm going to cheat here with my calculator, this would be 375, okay? And then we would have 3 times 5 times 5 times 5 going on. So we'd end up having 3 5s in that 4th row. Okay, so the recursive equation starts all the time, every time, no matter what. It's going to start f of n equals f of n minus 1. That never changes. But what does change is what we did. We multiplied by 5 as we went down this table. And then we were given, that's what this semicolon represents, given that we started with f of this 5 here equals, our number of dots we started with was 3. So this is the actual recursive equation, okay? So our start time was 5, our start dots were 3, and as we went down the table, this is saying, hey, you multiplied by 5 as you went down the table. Next problem, let's say we built a time machine. So that means for our time here, we started at -2, and we had 12 dots at time -2. At time -1, we had 6 dots. At time 0, we had 3 dots. So in this particular problem, right, we started with 12 dots, but this time I'm not multiplying by 2. I'm actually going to write this to the side right here. We're actually dividing by 2, but like we talked about yesterday, in geometric sequences, they don't like to use the division symbol, so we have to change this to a fraction that we multiply, and that fraction would be times 1/2. So really we're times and 1/2. And that means in the 3rd row here, we would have 12 times 1/2 2 times. Okay? And if you wanted to figure out the 4th row here, you would just times by 1/2 again. So in this problem, the recursive equation is going to be f of n equals f of n minus 1. And then once again, that common ratio was 1/2. Given that we started with, and I'll write the start numbers on the side here just because we have this going on. We started with a -2 for our time, and we started with 12 dots. So I wrote the start time to the side instead of right underneath, like over here. And here is our recursive equation. All right. Now let's do an example where we actually use the recursive formula, and you guys can see like why we have what we have going on. Okay, so we have so I told you sometimes it might not be an n. So we have f of x equals f of x minus 1 plus 5, given we started with time 1 equaling 7 dots. Now it wants us to find f of 2. Okay, so this means that this 2 we are going to use to replace this x and this x. Okay, so what I'm going to do is I'm going to put those 2's in right now. Everything else stayed the same. The only thing that changed was those x's, so I still have those f's. Okay, this guy's going to come back to play. You know, he's going to be that last minute bench seat, like in a football team, come win the game. So we have f of 2. We can't really do anything with this, equals. I do know 2 minus 1 though. So I know 2 minus 1 is 1. This plus 5 comes down because we didn't mess with that. Okay. I can't add 5 to this f of 1. However, I do know that f of 1 equals this 7. So that means I can substitute this f of 1 with just a 7. Notice that when I did that, the f in the parentheses went away. Just like over here, there's no f in parentheses with the 7 on this side. It's just saying this piece here, if you see something like this, it's going to equal 7. And that's what we did. Everything else gets brought down. Well, now I know 7 plus 5 is 12. And there we go. And I didn't talk about this in class, but if you watch these notes, we can have a bonus video moment. If I started making a little table, right, from this information we started with, well, I know this 1 would go here, and I know this 7 would go here, because we were writing that out earlier. I also know that, let me do purple, this 5 is meaning we add 5 as we go down. So this would be 12, this number would be 2, this number is 3, and this number would be 17. But that 2 and that 12 matches what we figured out. So really, we use the recursive to find the next set of numbers. One more, I'll do this a little bit faster. We have f of x equals f of x minus 1 times 2, given f of 4 equals 9. We are going to find f of 5. So once again, this 5 right here is going to replace these x's that are going on. So I'm going to write those 5's in right away. So all those x's are now gone because I've replaced them, I've substituted them. And I can't do anything with this 5 over here, but I can do 5 minus 1. So now I have f of 5 equals f of 4 times 2. I can't multiply this 2 yet to this f of 4 because that's not something we can do. However, this f of 4 equals 9. We wrote that earlier, that was given to us. So I'm going to replace this f of 4 with a 9. And that whole f of 4 goes away and is replaced by 9. Times 2 is still there. Okay, and now I get f of 5 equals 18. And once again, if you want to write a little side table over here, we can show this. F of 4 equals 9, so from our recursive, we know that this 4 is our time, this 9 is our dots, right? This times 2 means we are multiplying by 2 as we go down. So this would be 18, and the next time after 4 is typically 5, and that matches up. Okay, that's the end of this video. This is a good way to check. It might also help you on the homework that I didn't show the other students that were actually in class. Have a good day, y'all, and I'll see you next time.